around my arm, I'm not getting the whole thing. I'm getting like a ring around my arm. So I'm going to get what's called a washer. Okay. So what's it going to look like? It's going to look like I have the outside. So there's going to be a hole in the inside. It's going to be just a ring, also called a washer. This is a disc. The American code is A, and this is a washer. I think it's something about screws and nuts or something. Are we okay with why that slit gives me a washer and not a disc? Okay. How do I find the volume of this disc? If I can do that, or of this washer, if I can do that, I take the integral, I've done the problem. Okay. I'm going to call this little length over here dx. So that means that the washer is dx. But now this is no longer a cylinder. This is a cylinder with a hole in the middle. So I have to know not only the big radius, I also have to know the small radius because I have a big cylinder with a little cylinder sticking out. The volume is the difference of their volume. So the big height over here is going to be corresponding to the furthest my slit is from the axis of revolution. If this is x, then the furthest my slit is from the axis of revolution is that value over here. If this is x, that height is exactly what I get when I plug x into my parabola. So the height is going to be minus x squared plus twice x. Because it's just the height of the parabola depending on where my x is. Now the small radius, the little inside, that's going to be this portion over here. So this is my big radius, I can call it capital R. This is going to be my little radius, little r. And that height is going to be exactly the height that I get when I plug x into the formula for my straight line. And my straight line says that x1 x, the height is exactly x, y next. That means that the volume of my washer is the volume of the big cylinder minus the volume of the hole that I plucked out. The volume of the big cylinder is pi times its radius squared times the height of that cylinder. The height is that little dx. Now, the volume of the hole, right? Because this volume is taking into account that hole in the center that isn't there. So I now have to subtract the volume of the hole, which is pi times the radius of that hole is the little r, which is x, so x squared. And this I can write a little bit more succinctly as pi times minus x squared plus twice x squared minus x squared. Please ask. This thing. That is an x. X is what I found to be my little radius. Is that better? It should be x, right? Okay. Yes. Yeah. So dV is just the volume of my washer. the volume of my washer, if I draw it, so my washer is this thing with a hole in the middle. It's the same thing as taking the whole big thing and subtracting the little hole in the center. So now the volume VB, that's the volume of my washer, is going to be the volume of the big cylinder minus the small cylinder. The big cylinder has volume pi something, the radius squared, times, since this is dx, dx. Now I have to find out what the radius is for that outer disk. And that radius, remember the disk is what I get from taking that blue strip and rotating it around. So if I take this blue strip and rotate it around, pretend the blue strip went all the way to the axis and rotate it around, this whole thing is going to be the radius of the disk. And that is that radius there, that length there depends on x. Because if x is close to 0, it's going to be a small number. If x is close to something over here, it's a big number. So it depends on x. For each x, this height is exactly the y coordinate on this function, the parabola. So for each x, the y coordinate on the parabola is given by this formula. So that y coordinate is the value of my big radius. So that's why I plug in minus x squared plus twice x for the big this radius. Okay, maybe my picture is not very big. Okay. But for a chosen x, this is my outer radius, and then that's going to be my inner radius. So when I subtract the volume of the little guy, it's going to be pi times whatever its radius is, dx. If this is the slit that I'm rotating, the radius of the hole in the center is exactly this little height over here. And that height depends on where x is. If x is 0, there is no hole. If x is something over here, there'll be a bigger hole. So for my choice of x, this height is exactly the y coordinate corresponding to x along this function here. And this function here is the one that says that y is equal to x. So when I have x, corresponding y coordinate, which is going to be this length here, is also going to be equal to x, which is why you will see more examples. But this is still not there, don't worry. Now, why did I take the time to do it like this? You'll notice, I'll tell you in a moment. But the volume is the integral of, say, dv, which is pi times minus x squared plus twice x squared minus x squared dx. I think we're going to go from where to where. So x is allowed to be, x has to be something underneath this reason I'm rotating. The smallest x can be is 0. The biggest x can be is whatever the x is corresponding to that quantity of x. Make the two graphs equal to each other. Right? So I have to set x equal to minus x squared plus twice x, which means 0 is equal to x squared minus x, which means 0 is equal to x times x minus 1, which means my functions intersect at x equals to 0 and x equals to 1. And this is the x equals to 0 intersection, so this must be x equals to 1. So that means that x can be anywhere from 0 to 1. And now I have an integral. I can now find the volume by calculating. write down kind of thing that we noticed, and we're all in agreement with the notation. We have found the general formula for the volume of a surface of a solid revolution is the integral from A to B of pi times. I have to take the outer radius of my washer squared times the inner radius of my washer. Now, sometimes my inner washer won't be anything because my washer will be a stitch, and then my little R will be a exam. If I give you this question, you have to get to this point, and now we know how to evaluate this integral. We can use the fundamental of calculus, right? It's not that easy. You have to do some algebra, right? So if you're not comfortable with some high school arithmetic and stuff, this might be a difficult integral for you to find. However, I suggest in practice, I got wrong. So the answer was pi upon 5. Now, on an exam, I will most likely not ask you to find the volume. I'll ask you to set up this integral and not evaluate it. Okay. So if I'm testing you on this on the exam, I want to see can you get to this integral. And then you're allowed to leave it if I don't say that fundamentally. But on your own time now, using the fundamental of calculus and some algebra, you can calculate this thing as pi over 5. So the same thing is true for area between curves. If I tell you to set up the integral, that you need to find the area between two curves, you don't have to actually calculate the integral to get the area. If I say to set up the integral to find the volume of a solid revolution, then you can stop.